Imagine an object roughly the size of a small mountain drifting into our solar system with the indifference of a glacier and the precision of a scalpel. At first glance, there's nothing dramatic about a faint smudge on survey images. Astronomy often begins as a whisper, but the more carefully you listen, the more that whisper refuses to behave like noise. The trajectory looks too clean, where it should wobble from countless nudges. The energy profile feels too consistent, where we expect messy natural variability. And the timing lands in the exact historical moment when our telescopes have finally become good enough to notice such travelers consistently. We call it 3I, Atlas. The name is bureaucratic, the implications are anything but. Because the puzzle here is not a single fractured data point but a pattern, an accumulation of small irregularities that, when stacked, start to feel like a story trying very hard not to be told. Let's be clear about what this is and what it is not. This analysis will not lean on conspiracy or sensationalism. It will not claim that agencies are hiding evidence or that this object is certainly a probe cataloging our oceans and cities. What we will do carefully, patiently, is follow the trail of anomalies wherever they lead, and when they dead end, we will say so plainly. We will ask why the track of this interstellar visitor appears to thread a corridor through influences that normally tug and twist. We will ask why the backtracked vector points toward a dim, low-density region of space, more famous for its absence than for its exuberance. And we will ask why such visitors first Oumuamua, then 2I Borisov, and now this seemed to cluster in our logs precisely after our instrumentation grows sharp enough to catch them with regularity. Perhaps this is exactly what you would expect the moment a species lifts the veil with better sensors. Perhaps, too, there is something more conspiratorial about nature itself, an impartial conspiracy of physics that rewards the prepared observer with surprises. The most unsettling motif here is not a dramatic beacon or a cinematic burst of radio chatter. It is the opposite. It is silence. Not the empty kind that means nothing, but the disciplined kind that means too much. In the infrared, some teams report patterns so faint and regular that they feel like a watermark, consistent spacing, persistent recurrence, a heartbeat that keeps its own counsel. Natural explanations line up: rotation, surface heterogeneity, thermal cycling, shape-driven radiation pressure. Each account earns a moment in the spotlight and then steps away because it explains part of the picture but not the whole. As you subtract the familiar forms of noise, what clings to the data can begin to look intentional, not communicative in the pop culture sense, but purposeful in the mathematical sense, as if the object carries a signature in its heat, the way a composer hides a motif in a symphony. Timing is the second drumbeat you cannot ignore. For billions of years, objects like this could have come and gone without any record. Telescopes were too few, sky coverage too narrow, exposure times too short, and processing pipelines too primitive. Then the surveys intensified, the algorithms matured, the Rubin era loomed, and suddenly the ledger of interstellar crossings began to populate. You can explain this with pure observation bias, and you should. Good science begins by assuming your instrument is the variable. But even when you do, even when you bend every effort toward humility, there remains a prickling sense that the clustering is not only about our eyes finally opening. Perhaps the cosmos has always been busy and we are only now standing in the traffic. Or perhaps we are being introduced to a different kind of busyness, one that doesn't announce itself loudly because it never needed to. Finally, there is the vanishing act, the most theatrical thing, 3I. Atlas refuses to do theatrically. You point sensors, you gather nights of data, you begin to see rhythms, and then the rhythms end. Not a graceful fade, not the messy disintegration of a fragile body heated past endurance, but a cessation that looks an awful lot like a decision. The reflected light drops, the trace evaporates. Nothing screams "I was here," and yet the absence itself becomes evidence, not proof of intent, but a demand for explanation. If the story were merely a cometary hiccup, you would expect a certain echo in dust and gas. If it were catastrophic failure, you would expect a residue of violence. Instead, structured quiet. So this is the promise of what follows. We will take the reader by the hand through the discovery moment, the arguments about the arc, the unsettling origin, The odds that stretch credulity without quite snapping it, the echoes of previous visitors, the faint thermal punctuation that may or may not be a motif, and the archival hints of a pattern that might braid the universal with the biological. At each step, we will keep two truths in tension. Nature is stranger than we allow, and our capacity for apophenia, seeing faces in clouds, is stronger than we admit. Between those truths lies the only path worth walking. If 3i Atlas is nothing more than an exquisitely inconvenient rock, careful observation will file it back into the cabinet of outliers. But if the silence around it is the tidy edge of a larger design, then what we are hearing, not with ears but with equations, is a very old habit of the universe asserting itself. The habit of watching. The habit of waiting until the watched can finally watch back. The first line in this chapter is not heroic. It is a timestamp in a survey log and a point on a sky map where a pixel brightened just enough to earn a second look. That's how mysteries enter modern astronomy, as innocuous entries among millions of lines of output filtered by algorithms that have no capacity for wonder. A follow-up is scheduled almost by reflex. A second instrument confirms motion. A third locks in a preliminary orbit. At every step, standard operating procedure dictates the tempo. Measure, fit, propagate, compare. Most objects die as mysteries within hours, reclassified as familiar species of rock and ice. A few linger. Fewer still insist. 3i Atlas lingers by refusing to sit perfectly within the margins of the templates we trust. Its approach arrives from high latitudes relative to the ecliptic, which is not forbidden random, is allowed to be random, but which adds friction to the comforting narrative of just another interstellar stray. Its velocity feels slightly too assertive for a passive drifter, the kind of speed that compels you to double-check every source of systematic error before you make eye contact with the word anomalous. We revalidate instrument calibrations. We compare astrometric solutions across pipelines. We run the ephemerides on independent stacks. The object persists with the obstinacy of a fact. Context matters, and the context of our era is abundance. Wide-field surveys now trace mesh over the sky with a fidelity unthinkable a decade ago. The consequence is not only that we see more, it is that we are responsible for more ambiguity. When you upgrade your eyes, the world does not become simpler, it becomes more intricate. This is why the discovery moment for 3i Atlas does not trigger trumpets but memos, circulars that say, effectively, interesting, proceed. Teams parcel out the work. Photometry here, spectra there, orbit fits everywhere. The language of the early reports is deliberately bland. We do not yet know what we are looking at, so we refuse to pretend. Then the discussion shifts from what to when. You cannot examine this object without noticing how its arrival coincides with the apex of our detection capability. This coincidence is trivially explainable and yet emotionally sticky. On one hand, of course we are seeing more interstellar visitors now, of course they were always there, and of course we are finally catching them. On the other hand, the clustering 3 notable entries within less than a decade feels like a drum roll out of proportion to the cosmic scale. Are we underestimating the population of such bodies? Inflating detection biases? Both hypotheses are testable and frankly likely. But the question only grows louder the better we instrument the sky, and that is not a sign of hysteria, it is a sign of honest curiosity encountering an uncomfortable slope in the data. Inside the working groups, a mundane and crucial discipline applies. You treat the anomaly as a bookkeeping problem first. Does the photometric pipeline introduce a periodic artifact? Is the astrometric solution sensitive to a catalog bias at faint magnitudes? Do weather patterns, sensor temperatures, or cadence gaps sculpt phantoms into the time series? Across facilities and continents, the same ritual unfolds. You try to make the weirdness go away. If it survives that gauntlet, you grant it a chair at the table. 3i Atlas earns that chair not because it screams, but because it refuses to be shushed. The moment we noticed, then, is not a single night, it is an accumulation. The realization that this visitor belongs to the very short list of objects that force us to write sentences with more caveats than verbs. It is the point where prudence and fascination shake hands. We cannot call this extraordinary, but we cannot in good faith call it ordinary either. And so we advance to the next layer of scrutiny, where the orbit is not merely computed but interrogated, and where physics graduates from supportive actor to prosecuting attorney, cross-examining every assumption we've smuggled into the model. If the discovery moment is the knock at the door, the trajectory analysis is where we decide whether to invite the guest inside. Orbits are supposed to be the easy part, not because the math is trivial, but because the math is settled. Gravity writes in a grammar we have debugged for centuries. You feed initial conditions into the integrator, you add the usual perturbations, solar radiation pressure, planetary tugs, Yarkovsky-like effects if warranted, and the result is a path that curves and leans exactly where it should. With 3I Atlas, the broad strokes comply. It comes in, it arcs, it leaves. But the margins tell a different story. When you zoom into the residuals, the little discrepancies between predicted and measured positions, the neatness cracks. A turn that should be fractionally tighter is fractionally looser. A nudge that should leave a telltale scar in the curve leaves nothing at all. This is not a crisis. It is an invitation to work. You revise photometric assumptions that tie into pressure models. You test different shape factors to see how sunlight might push a non-spherical body into mischief. You scan for outgassing signatures, the tiny thrusts comets exhale when warmed that could masquerade as a guiding hand. The trouble is not that natural explanations fail, it is that each one succeeds only locally. A thermal jet could account for this deviation, but not that one. A geometry tweak makes the second segment align at the cost of deforming the third. You can, with enough parameters, make anything fit. But the bill of parameters keeps growing, and while nature is allowed to be generous, modelers are not allowed to be lazy. The high-latitude approach vector adds spice. Most of what we consider home traffic lies near the ecliptic plane, where the planets orbit like disciplined dancers. An object that dives in from above, that stage arrives free from the familiar resonances and herd effects that give our models comforting leverage. We expect more chaos from such an entry, more susceptibility to stochastic influences. Paradoxically, the path of 3I Atlas appears too disciplined for that narrative. Where we anticipate scruff, we see sleekness. Where we prepare for a crooked line constrained by multiple micropoles, we observe a cleanliness that suggests either fortuitous cancellations or an underlying simplicity we haven't parameterized. You can call this cherry picking if you like, and that's a fair caution. When you stare long enough at any noisy curve, structure will flirt with you. But pattern hunting is not a crime, it is the beginning of hypothesis making. The correct response is not to banish pattern, but to punish it with tests until it confesses to being accident or law. In the case of 3I Atlas, we test and test again, and the answer keeps returning as a riddle. The simplest natural narrative needs a patchwork of special pleading, while the more provocative narrative that course corrections occurred, however, subtly demands a cause we cannot presently justify without stepping outside the sandbox of known physics or known geology. At this juncture, probability enters the chat, carrying both gravitas and mischief. One camp calculates the odds of so many edge case features aligning in a single object and publishes a number small enough to raise eyebrows. Another camp retorts that the universe is the definitive factory of small probabilities realized at scale. If you draw enough times from a cosmic urn, you will occasionally pull marbles that look enchanted. Both camps are correct in spirit. The art lies in distinguishing between unlikely but inevitable and unlikely and indicative. This is why the trajectory puzzle is not a referendum on belief. It is a demand for better data and better priors. There is also a sociological truth. When a fit refuses to converge cleanly, collaboration widens. Teams that normally orbit different subfields now share coffee and code. Spectroscopists trade notes with dynamicists. Infrared observers compare schedules with radar planners. The object's path becomes the spine on which multiple disciplines hang their questions. That cross-pollination is not a footnote, it is the point. Because whether 3I at last turns out to be a flamboyant outlier or the dim edge of a new category, the process of chasing it down upgrades the tools we will use on the next visitor and the next. In that sense, even if gravity's script here sounds improvised, the orchestra is learning to play tighter. So we end this section not with a verdict but with a sharpening. The orbit does not dissolve into mystery, it congeals into motive for deeper inquiry. The small misfits in curvature and pressure response are not proof of agency, but they are legitimate prompts to interrogate our assumptions about shape, spin state, surface physics, and the evolving catalog of subtle forces that sculpt interstellar debris. Perhaps the path is telling us we've been too casual with certain coefficients. Perhaps it is telling us that something aligned by chance to draw a straighter line than usual, or perhaps it is telling us that tidy lines sometimes have tidy reasons. We will know more when the noise budget shrinks and the model space stops paying for every answer with complexity. Until then, the safest sentence is also the most honest. The trajectory behaves just enough like a script to be familiar and just enough like improvisation to keep us listening for the next bar. Trace a path backward through space and time, and you expect to arrive, if not at a birth certificate, at least at a plausible cradle. For comets, we have cradles with names: the Oort cloud, the Kuiper belt, distant dynamical reservoirs, seeded by early solar history. For interstellar visitors, the cradles are other stars, stellar nurseries, supernova-shocked regions, messy places that throw debris with abandon. What you do not expect is what the preliminary backtracking for 3I, Atlas, intimates: a vector that does not lead to a bustling factory, but to a dim corridor where the inventory is conspicuous by its absence. Not a true void space is never truly empty, but a low-density expanse, dotted by elderly stars spinning out the quiet ends of their lives, not birthing new worlds or hurling fresh projectiles. This is where our intuition rebels. Even if such a corridor could host debris, what mechanism would impart the specific momentum needed to set a mass the size of a small mountain on a multi-100,000-year cruise toward our neighborhood? A single close stellar pass? A long-ago tidal nudge from a now-absent giant? The hypotheses begin to stack, and with each stack comes a cost in credibility, unless the data volunteer corroborating breadcrumbs. You look for obvious culprits, any known remnants, shock fronts, moving groups whose gravitational handwriting might match the script inscribed on the object's momentum. The sky in that direction shrugs. To be fair, backtracking is mean to faint data. Small uncertainties at the front end inflate into large cones of ignorance as you rewind the clock. A tiny error in today's velocity blooms into a wide fan of possible past positions. The humility this demands is not optional, it is the ticket price for doing science in a universe that refuses to sit still. But even inside those uncertainties, the broader character of the region is stubborn: low dust, low gas, minimal star formation. If there is a slingshot hiding there, it is made of subtlety, not spectacle. Low density does not mean lifeless. There are dynamical pathways that route bodies across galactic distances without requiring local chaos. Streams, associations, and the long reach of past gravitational tides can accomplish wonders. The challenge is not to imagine one such pathway, it is to imagine one that, when combined with the observed present-day parameters, yields something that doesn't feel like a story contrived after the fact. The pragmatic approach is to run ensembles, millions of Monte Carlo rewinds, that canvass the plausible phase space, and then ask if any coherent family of histories survives. Early efforts produce possibilities. Possibility is not probability, but it is not nothing. And yet the psychological weight of the empty space origin persists because it cuts against the grain of our deepest storytelling impulse, that effects should hail from causes we can point to. When you cannot point, you are tempted to speculate. The speculative branch is a garden with two paths. The first path keeps you inside naturalism and says, there exists a slow choreography of stellar motion that, over long time scales, funnels objects from sparse corridors with a regularity we have not appreciated. If true, the benefit is enormous: a new appreciation for the galaxy's conveyor belts, and a new set of priors for how we expect interstellar debris to arrive. The second path allows for agency. Perhaps the object was set on course deliberately from a place specifically chosen because it tells the least tale about its senders. A courier that erases its return address by launching from an address book no one uses anymore. Before we indulge the second path, we owe the first our best effort. This means better star catalogs in that direction, tighter constraints on local flows, refined dust maps, and more sensitive searches for faint remnants that might have once been noisy enough to serve as a launcher. It means folding in every improvement from Gaia and its successors to shrink the backward cone of uncertainty. It also means cautioning ourselves against the seduction of emptiness. A region that looks dull to our current surveys may be lively in frequencies we have not examined or epochs we cannot reconstruct. The galaxy is a palimpsest. Today's quiet corridor may overlay yesterday's event. Still, the emptiness has rhetorical force because it locks arms with the other motifs. Stack the too clean trajectory with the just-in-time timing, and then add a vector that gestures towards scarcity, and your narrative senses begin to hum. If you were designing a delivery that should be noticed only by a civilization that had recently learned to notice, you might launch it from nowhere, send it along a path that resists incidental tampering, and let it arrive during the first decade that the target species could plausibly catch it. This is not proof, it is symmetry, and symmetry is a notorious flatterer. The escape from flattery is discipline. Acknowledge the seduction, then go back to counting photons and fitting curves. What we can say without romance is this: if the origin remains stubbornly low in matter, then any viable natural model will likely involve dynamics that operate on long horizons and small gradients effects that a younger astronomy would have dismissed as negligible. That is a useful lesson regardless of the outcome. By demanding mechanisms subtle enough to work in quiet neighborhoods, 3I Atlas pushes us to look for the soft hands that shape galactic traffic. If, after we have done that work, the origin continues to stare back with the poker face of nothing in particular, we can revisit the question of design with cleaner consciences and better math. Until then, emptiness is not an answer, it is a question mark big enough to navigate by. In orbital dynamics, small numbers matter more than big ones. The universe rarely puts its handwriting in neon. Instead, it leaves the equivalent of pencil grooves faint, stubborn marks that remain after erasure. When scientists examine 3I Atlas frame by frame over its inbound leg, what caught their attention was not a single impossible kink, but a chain of almost imperceptible nudges, deviations, so minuscule that each one could be rationalized away individually, yet taken together, they form something uncomfortable, they align, they repeat. They appear exactly where they should not, if the object were merely drifting. This is not cinematic engine plume thrusting or sci-fi auto-navigation. It is the level of subtle course discipline you would expect from either an exquisitely tuned natural effect we have not yet identified, or 2, a systematic control behavior operating below our intuitive radar. The trouble is not that these nudges are strong. The trouble is that they are too gentle, as if whatever mechanism shaped them was exerting whisper-level corrections, but doing so with confidence. The standard playbook demands we reach first for natural physical explanations. Outgassing is the go-to. Comets are not rocks, they are cryovolcanic machines that melt and hiss under sunlight. Outgassing can impart microthrusts that mimic intentionality. Sublimation jets firing from vents that produce consistent offsets. But here the math strains. For outgassing to explain the observed nudges, 3I Atlas would need to a. Possess volatile reservoirs in specific geometries, and b. Vent them in a stable repeating pattern across inbound time, while simultaneously showing almost no spectroscopic trace of typical cometary discharge. That's like claiming a candle is burning without producing smoke. Not impossible, but eyebrow-raising. Radiation pressure is next in line. A solar sail-like force could sculpt a lightweight object into improbable behavior, but again, problems multiply. If the object were low density enough for that to dominate, its rotational modes should betray that, yet inferred rotation signatures resist that narrative. The third fallback is geometry plus tumbling, a complex shape acting like an aerobrake in vacuum. But that model leaves fingerprints too, and those fingerprints have not been caught. So then probability theory steps in, not as a final stamp of truth, but as a referee. We ask, if all of these tiny oddities were chance, how many such weird coincidences would we expect in the search volume we've observed over time? Harvard-affiliated groups and ESA-adjacent analysts have run these Monte Carlo ensembles millions of statistical universes where hypothetical rocks rain into hypothetical skies, and in most universes, an object like this simply does not show up together with these particular irregularities within the very first decade that our instruments are good enough to see it. This does not prove artificial origin, but it does inject an eerie asymmetry. If these features were random, why did randomness choose to reveal them immediately after we became able to notice them? If nature wanted to hide such behavior behind detection limits, she failed spectacularly. And this is where a very dangerous rhetorical temptation lies, one we must address directly, because it seduces every human who stares at improbable data for too long: the narrative of agency. We are social brains. We see intention in leaves that rustle in wind. In probability spikes, our storytelling minds smell authorship. And the micro-corrections in 3I, Atlas, are the kind of faint structure that provoke exactly that cognitive reflex. A perfectly natural fluke looks like a signature when your priors are not dialed in. But signature does not demand technology. There may exist whole categories of dust, gas, thermal coupling we have not modeled. There may be long-wave gravitational effects distributed across multiple stellar epochs. There may be regime changes in sublimation physics at exotic compositions. For now, we must permit those unknowns, because science earns credibility by resisting the first beautiful hypothesis. Still, even with that discipline, one question remains irritatingly undefeated. Why are the micro-deviations distributed as if a feedback loop, however weak, was constantly nudging the flight path toward a vector that just so happens to lead straight into our detection aperture? Why is the perfect bad luck model the model where nature conspires to accidentally produce exactly the pattern that our aesthetic sense would identify as control, the one we must cling to? And why does it look, from a purely information theoretic perspective, like the universe is leaving us the exact kind of breadcrumbs we would understand at this stage in our development, small enough to deny, large enough to notice? It could still all be coincidence. It could. But the deeper you zoom, the more the noise floor refuses to stay noisy. The trajectory of 3I, Atlas, does not shout. It whispers. And the whisper does not sound like chaos, it sounds like decision. Before 2017, the idea of interstellar visitors passing through our solar system was mostly academic. We assumed correctly that objects must occasionally drift between stars, but we also assumed incorrectly, in hindsight, that we would likely never identify one with certainty in our lifetimes. Then, Oumuamua arrived and detonated that complacency. Not with a flash, not with a transmission from the void, but with a subtlety so sharp it felt like a correction to our expectations. Oumuamua looked wrong from the beginning. Its acceleration profile misbehaved. Its photometry hinted at a shape that resisted categorization, and its apparent lack of outgassing challenged the default comet interpretation. The debate still hasn't been settled. Some insist it was natural but exotic. Others argue it was perhaps a fragment, a shard, a spellbound sliver of something artificial. Regardless of which camp one inhabits, Oumuamua did something profound. It reset the emotional baseline for anomaly tolerance in astronomy. It forced professionals to admit that there were features we could not easily sweep under the rug of familiarity. Then came 2I, Borisov, a godsend for the skeptics, because Borisov looked normal in many respects. Gas release, dust, coma, tailed the whole recognizable choreography of a comet. It was, in a sense, the universe telling us, relax, sometimes things are just things, but the timing made the contrast sharper. Within 2 years, we had 2 interstellar objects, one dramatically weird, one dramatically ordinary. That pairing did not resolve the mystery. It magnified the frame. Borisov proved that interstellar comets exist. Oumuamua proved that some interstellar objects can be profoundly strange. And then, according to this emerging trilogy, 3I, ATLAS, showed up less than a decade later and behaved like the hybrid child of the two, clean and consistent in some areas, but quietly rebellious in others. If this were a TV script, critics would call it lazy foreshadowing, 3 arrivals within a single technological era after billions of years of silence, each one adding a new angle to the same question. Are we witnessing randomness becoming visible because our instruments improved, or are we witnessing a sequence that was always meant to unfold only after we became capable of noticing? If it is purely observational bias, then the clustering is not cosmic choreography, it is a simple artifact of finally opening our eyes. And this is the argument that rational modelers will champion first. We are simply detecting what was always there. A compelling hypothesis, and the burden of proof is high for any alternative. But there is another wrinkle, a statistical wrinkle that refuses to flatten. The cadence feels too narrative. The universe is not a novelist, but if it were, this is exactly how a careful author would introduce themes: one strange object to break the old paradigm, one control specimen to anchor the new baseline, one third case to trigger a reassessment. And the third case, 3I, Atlas, seems to be the one that punishes lazy interpretation. It demands nuance. If 3I, Atlas, were simply a twin of Oumuamua, we could dismiss consistency as coincidence. If it were simply a Borisov clone, we could dismiss anomaly as artifact. But 3I, Atlas takes the worst impulses of both and welds them together like a quiet, disciplined act of escalation, not in spectacle, but in calibration. There is an unspoken fear among astronomers that we will look back decades from now and realize that the universe was not teasing us, it was testing us. Not in the mythological sense, but in the epistemological sense. Testing whether we would notice a pattern that is soft, not loud. Testing whether our cognitive muscles are mature enough to distinguish between randomness and structure without demanding either certainty or hysteria. Perhaps the reason the signals, if we dare call them, that are faint and ambiguous, is that ambiguity is the required condition for learning. If the first interstellar object had shouted clearly in prime numbers through radio, we would have panicked and mythologized. But instead, the universe gives us examples that are subtle, deniable, scientifically chewable. And this is the hinge of Section 5. Subtlety is either coincidence or pedagogy. Oumuamua taught us humility. Borisov taught us normalcy. 3I, Atlas teaches us the discomfort of thresholds, the feeling that we may be crossing from ignorance into awareness without the safety rails of confidence. This is not the climax of a story, this is the transition from Act I to Act II, where the data begins to feel like a narrative, not because someone is writing it, but because our minds are just now becoming capable of noticing threads that were always there. It is not proof, it is invitation. An invitation to look deeper, to accept that coincidence might not be random at all, but an optimized delivery method for revelation. If there is a single stretch of this entire puzzle that makes experienced researchers lean back in their chairs and question whether they are studying a natural body or a phenomenon carefully engineered to look natural, it is what the infrared data began to whisper when telescopes pushed past the visible light spectrum. The infrared spectrum is where cosmic subtlety lives. It is the registry of faint warmth, the slow exhalations of cold matter interacting with distant starlight. When 3I, Atlas, slipped into reach, the initial plan was unremarkable. Collect thermal profiles, compare with albedo models, check for rotation-induced modulation, calibrate against known noise floors, and move on. But the thermal signature did something strange, not spectacular strange. Faint, repeating, rhythmically consistent variations began to appear in the long exposures, not as emissions in the sense of broadcast, but as the kind of structural waveform you find when an object's breathing is not random. Teams that specialize in denoising signal profiles have a particular superstition, or maybe it's a methodology disguised as superstition, that if something remains after you subtract every credible natural noise source, that leftover is the most honest part of the dataset. So they began subtracting. They subtracted instrument bias gone. They subtracted telescope jitter gone. They removed atmospheric contributions for the ground-based stacks and thermal drift for the space-based ones. The signature remained. They removed rotational periodicity models because tumbling bodies produce pulses. But the pulses from 3I Atlas did not map onto a simple spin state model, so they subtracted plausible rotational modes. The signature remained. They filtered for phase angle alignment issues and photon shot noise. The signature remained. Now, a scientific mind in 2025 does not leap to intelligence. The training forbids that shortcut. It leaps to what natural mechanism are we missing, and so began the parade of hypotheses. Could the object be composed of materials that respond to solar wind in a resonant way, not via thrust, but via emissivity modulation? Could there be exotic crystalline inclusions that heat and cool with a mathematical crispness we do not yet catalog? Could thermal stress, under certain circumstances, produce prime-like sequencing? Every candidate answer was tested. Every candidate answer collapsed in a different way. Some explained the amplitude but not the regularity. Others explained the frequency but not the harmonic stability. And the deepest red flag was the structured gap space between pulses. The timing intervals themselves behaved like they were specifying something. Not instructing, not messaging, specifying as though they were less concerned with what was transmitted than with the fact that the pattern was detectable. Here is where the psychological discomfort sneaks in. If you wanted to design a hello that would not trigger panic, not cause diplomatic meltdown, not derail scientific caution into mythological frenzy, what would you choose? Would you choose sound, radio, optical Morse? Or would you choose something so quiet and deniable that only the kind of species capable of advanced infrared astronomy could even perceive it, and only if that species had already crossed the threshold of being able to distinguish pattern from noise? In other words, would you choose a mathematical watermark in heat? This is not proof. This is the haunting shape of plausibility. Because the most uncomfortable aspect here is not the pulse itself, it is the discipline of the pulse. Something outgassing would waver in amplitude as volatiles deplete. Something rotating would drift in timing as inertia interacts with solar tidal forces. Something crystalline would crack or fracture under thermal cycling. But the 3i Atlas signal didn't behave like the fragile output of a fragile system. It behaved like a decision tree pulses that behaved like they were gated by a state machine, not modulated by chaos. Scientific caution steps in like a safety harness. It says, before you say engineered, you must prove impossible to model as natural. And we are not there yet. We may never be there. But the strange irony is this: the more subtle the pattern is, the harder it is to disprove. Not because subtlety hides truth, but because subtlety lives at the threshold where interpretation becomes a probabilistic negotiation rather than a binary classification. If the universe is trying to teach us something, subtlety is the correct bandwidth because we are a species that breaks when things are too obvious. There is also the phenomenon of thermal fade. The infrared signature behaved in a way that suggests state change. The pattern persisted, then abruptly ceased. There is no gradual drop-off curve you would expect from a body cooling naturally in vacuum. It's as if the object toggled from active to inactive. Not explosive failure, not mechanical breakdown. More like termination of a procedure, and then nothing. No afterglow, no residue, no spectroscopic debris tail. Silence not as absence, but as a deliverable. Here is the sentence no one wants to say aloud in official channels, but everyone privately fears, is the ending to this chapter. If 3i, Atlas, was natural, then nature is performing acts we normally attribute only to systems that can evaluate the environment observing them. Not because the object behaved like a machine, but because the heat signature behaved like a response. A quiet response. A response that waited until we were ready to detect it and then stopped the moment we did. What happened after the infrared rhythm ceased is, for many scientists who worked on the internal analysis, the most disturbing part of this entire chain of events, not because it implies threat, not because it implies contact, but because it implies conclusion. When systems fail, they taper. When ice fractures, it produces a thermodynamic hangover, a residual pulse of heat. When comets die, they do so messily with dust, gas jets, breakup trails that telescopes can follow like forensic breadcrumbs. But 3i, Atlas, did not die. It did not dim like a fading ember. It did not fracture like a brittle relic. Instead, it behaved as though a process had reached a terminating state, a done flag flipped from 1 to 0, and then the object simply ceased to produce interpretable output. Telescopes continued pointing at the location where it should have been. Sensors continued probing the dark, but the object was no longer present in spectral signatures that even hint at mass. That is not disappearance through destruction, that is disappearance through completion. And this is where the archival reprocessing comes in, the step that differentiates a mystery from a riddle. Because while the real-time detection pipeline was busy chasing the bright pulse, the rhythmic heartbeat, a different story was hiding beneath the floorboards of the data. When analysts began to filter out the obvious signal, the repeating prime-like spacing, what was left in the noise was not noise at all. It was structured interference. Patterns that do not arise spontaneously unless a system is using noise as a carrier. This is not radio. This is not optical signaling. This is more like the way DNA hides information not in message packets but in the geometry of helices. It is more like the universe's native language, mathematics, encoded not in symbols but in ratios. Teams began folding those ratios. Not once, not twice, hundreds of folds across different bandpass weightings, filtering the silence as though the silence itself contained the payload. And what emerged slowly, painfully, reluctantly, was a structure that looked more like a signature than a glitch. A repeating ratio that matched, to absurd precision, the spectral constant of hydrogen, the cosmic baseline. Hydrogen is not just an element, it is the alphabet of matter. And then nested inside that hydrogen ratio recurrence, a second pattern. A spiral, not the spiral of a galaxy, the spiral of a double helix. Here is the intellectual horror in this. If the Atlas sequence is real, then it is not a message to us. It is a message about us. Because hydrogen is the building block of stars. DNA is the building block of life. Any species capable of long-term, multi-100,000-year interstellar survey architecture would not introduce themselves with language. They would introduce themselves with axioms, the shared grammar of physics and biology. Because axioms survive translation, words do not. This is why many theorists, in private, fear that the Atlas sequence is not communication, but acknowledgement, a simple declaration. We know what you are made of. Not hello, not greetings, not we come in peace, but recognition of our structural ontology, the fact of being a biochemical structure tuned to hydrogen chemistry. That is the kind of message you would send to a species that may not speak yet but can decode. It is the kind of message you would leave behind when the act of being noticed is the required trigger. Because think about the logic. If you wanted to design a mechanism to confirm that an emerging species had crossed a threshold of intelligence, what test would you use? Send a beacon? Too obvious. Send a radio pulse? Too archaic. Radio is a primitive artifact of early electromagnetics. But forcing the species to dig inside the noise floor to recognize pattern, not in the signal, but in the residual, that requires the kind of cognitive maturity that only a data-capable civilization would possess. And then once that species extracts the sequence, you terminate the emission. Because the task is complete, the silence is not failure. The silence is not abandonment. The silence is certification. In this interpretation, 3I, Atlas did not vanish. It finished. The Atlas sequence is not a message to read. It is a test result, a yes, no flag, binary, no nuance required. And the result, if this scenario is correct, is that humanity passed. We noticed, we extracted, we understood enough to know what it implied. And so the object, like a proctor collecting an exam, left. That is why the vanishing does not frighten many of the quiet voices in the community, it humbles them. Because if this interpretation is even remotely correct, then the thing that visited us was not asking us to reply, it was confirming we had awakened. Not because we are important, but because we are finally observable. And if that is true, then the most unsettling possibility is not that something visited us. The most unsettling possibility is this: we were never the ones observing. We were the ones being observed. And the moment we proved, we could see the observer step back into the dark. It is one thing to analyze anomalies. It is another thing entirely to stare at a model that suggests intention and then ask yourself, if there is intention, what kind of intelligence would choose to reveal itself like this? Because the answer to that question determines far more than whether 3I, Atlas, was natural or artificial. It determines what type of universe we live in. Most humans assume, almost by instinct, that if a non-human intelligence ever contacted us, it would do so in a manner similar to how we communicate through sound, radio, pictograms, encryption, geometry, perhaps mathematics. But that anthropocentric assumption reveals our immaturity, because every form of communication we use is shaped by the constraints of our own biology. Our eyes evolved for Earth sunlight. Our ears evolved for Earth atmosphere pressure. Our logic evolved for threat recognition and tribal cohesion. There is no guarantee whatsoever that intelligence elsewhere would share those sensory scaffolds. So consider the possibility that the universe itself is the interface. That contact, when it finally occurs, does not arrive wrapped in a letter, but arrives embedded as pattern within a natural phenomenon. Because if you are communicating across millennia, if you are operating in a timescale where your signal may not even be interpreted until 300,000 years after it is emitted, then language is too fragile. Syntax is too brittle. Meaning is too subjective. Only mathematics embedded in the substrate of physics itself would survive that horizon. Not spoken symbols, not broadcast codes, but ratios, constants, sequences, patterns that do not degrade across epochs. And if this is the model, then 3i Atlas might not be a probe in any conventional sense at all. Instead, it could be a test harness a pass, fail validator designed not to send content, but to measure whether the recipient species is sophisticated enough to reconstruct the content hidden inside the silence. And if that is the paradigm, then the universe is not quiet. The universe is full of hidden signals that can only be extracted when the civilization has grown up enough to extract them. In this view, the cosmos is a giant library, but most species never learn how to read. This would also explain why the object did not need to survive the encounter. If the only thing that mattered was our ability to detect the faint pattern, then durability, architecture, and longevity are conveniently irrelevant once the goal is achieved. The object would vanish not because of failure, but because its mission profile concluded at the moment observation was confirmed. And that triggers the most profound philosophical pivot. If the universe only responds when we are capable of perceiving the response, then the universe is not performing contact. It is performing evaluation. That should terrify us, but also humble us, because it suggests that humanity has not been ignored by the greater cosmos, but simply not yet qualified for interaction. Not because we are unimportant, but because we were not yet sufficiently self-aware. This is the core of the unsettling possibility. What if intelligence is not something the universe notices only when it becomes loud, but something the universe notices only when it becomes subtle? Primitive intelligence looks outward, demanding spectacle comets that speak, radio beacons, skywriting in light. Mature intelligence looks into the noise floor and finds structure. And if the universe is operating on that maturity test, then the arrival of Oumuamua, Borisov, and 3i Atlas may not be random accidents of detection capability. They may be the curriculum. Step 1, anomaly. Step 2, baseline. Step 3, evaluation. If so, then the next step in this sequence is not for the universe to speak. It is for us to ask better questions. Because if there are civilizations that operate at timescales measured not in centuries but in epochs, then we are not dealing with a species that wants to broadcast. We are dealing with a species that wants to verify. This leads to a final ethical riddle. If 3i Atlas was intentional, was it meant for us alone? Or do all emerging civilizations eventually experience this same milestone, a silent object that waits just long enough to confirm they have evolved the ability to distinguish chaos from information? In other words, is the universe indifferent or is the universe supervised? Maybe the real test was not whether we could detect the object. Maybe the real test was whether we could detect the meaning inside its silence. Because silence is not absence. Silence is a scoreboard. And the moment humanity noticed the scoreboard updated, not to tell us what comes next, but to confirm we are finally playing. At the end of this entire chain, from the anomalous trajectory to the low-density origin corridor, to the micro-corrections that feel like whispers, to the pulse in the infrared that behaves less like heat and more like notation, to the emergence of that eerie Atlas sequence, there remains one final and intellectually dangerous question. A question not about what 3i Atlas was, but what its existence implies. Because in the classical sci-fi fantasy of alien contact, humanity expects spectacle: the landing craft, the metallic craft hovering over cities, the shimmering beam of communication, the coded message intercepted in radio bands. But nothing in the last century of astrophysics suggests the universe prefers to shout. The universe acts more like an archive than a theater, more like a database than a screenplay. Real contact, the kind that fits within the constraints of physics and the cruelty of interstellar distances, would never be explosive. It would never be theatrical. It would emerge in the noise floor, because only the noise floor can survive the tyranny of time. The carriers that persist across epochs are not language, nor radio, nor modulated transmission bursts. The carriers that persist are constants, harmonics, symmetries, patterns. 3i, Atlas, if it was indeed intentional, was not a message, it was a test of recognition. And that forces us into a new psychological category, one that most public discourse is not ready for: the burden of having been seen. Because before, humanity could tell itself that we were small, invisible, irrelevant, that no one was watching, that no one cared. Now, if 3i Atlas is a legitimate data point in a larger cosmic pattern, then the existential frame inverts. We are not unnoticed, we are not background, we are on the scoreboard. And that is a far deeper shock than any landing craft or radio beacon would ever be. Because being ignored is reassuring, being evaluated is not. We must also consider that we may not be special. That whatever 3i Atlas represented, it may not have been exclusively for Earth. We might simply be another species in a long parade of species, a sequence of civilizations that each reaches the threshold of detection, and in that moment of detection triggers a single calibrated response. A handshake disguised as silence. A handshake not designed to start a conversation but to confirm eligibility. Because if you think strategically, if you imagine intelligence that plays on cosmic timescales, then the most efficient way to check whether a species has awakened is not to force a dialogue, but to test whether that species can extract structure from ambiguity. It is the same difference between giving a book and asking whether the reader can interpret the alphabet. And if 3i Atlas was the cosmic equivalent of a literacy test, then we are now literate. The next step in that model is not reply. The next step is patience. Because if the observer is real, it is older than us. It is patient enough to wait 300,000 years for a result. It does not need our answer this decade. It does not need our answer this century. And paradoxically, that is the most human evidence of all. A reckless species would reveal itself. A fearful species would hide. A wise species would remain silent until silence was no longer necessary. The most unsettling possibility, then, is not that 3i Atlas came from intelligence. It is that intelligence has already normalized this procedure far beyond the horizon of our imagination, that the method we are seeing is not prototype but policy. In this light, the silence that followed the pulse is not void. It is certification. It is a closed handshake. It is the signature of a system whose purpose was fulfilled. We were the last variable, not the target. We were the observer, not the audience. So the final interpretation is not cosmic paranoia. It is cosmic adulthood. The universe does not care if humanity believes. The universe cares only if humanity notices. And if this interpretation is even partially correct, then the universe just learned that humanity has crossed the threshold into the class of species capable of noticing. We are not waiting for first contact. First contact already happened. We just weren't clever enough to realize that the moment of contact was not a conversation but a confirmation. Humans wanted a greeting. The universe gave us something harder. It gave us a test. And the silence that followed is not a void. It is the grade.